Hello there. Welcome to CXC Math TV. Today we will be looking at multiplication of matrices. Alright? Now, whenever we're multiplying matrices, we first want to start with what is known as scalar multiplication. Scalar multiplication is just multiplying a matrix by a constant. Constant meaning a number. The best way to understand it is with an example. So example, let A be the matrix 2, 7, 2, 3, B be 1, negative 3, 5, 2, 1, 4, C be 2, 9, 5, 1. We need to find 5 times A. Let's also find a half of B and 5A plus 3C. So let's look at it. Number 1. To find 5 times A, we're going to multiply all the elements inside of matrix A by 5. So it's 5 times 2, 5 times 7, 5 times 2, 5 times 3. That gives us 10, 35, 10, and 15. Nice. And so 5 times A works out to be 10, 35, 10, and 15. Cool. Now, let's say we were asked to find a half of B. Go ahead and find a half of B. So to find a half of B, it's just going to be a half of 1. So it's a half times 1, a half times negative 3, a half times 5, a half times 2, a half times 1, and a half times a quarter. That works out to be a half, negative 3 over 2, 5 over 2, 1, a half, and 2. Cool. Now we need to find 5A plus 3C. So 5A plus 3C, we already found 5A in part 1. And we need to add 3C to it. So it's 3 times the matrix C, which is 2, 9, 5, 1. 3 times 2 is 6. 3 times 9 is 27. 3 times 5 is 15. 3 times 1 is 3. And so 5A plus 3C, we go ahead and we add corresponding elements. 10 plus 6 is 16. 35 plus 27 is 62. 10 plus 15 is 25. And 15 plus 3 is 18. And so 5A plus 3C is 16, 62, 25, 18. Now that is known as scalar multiplication. Now, the next thing to talk about is how do we go about multiplying two matrices? So in order to multiply two matrices or to multiply two matrices, we first need to examine if the two matrices are compatible. What do we mean by compatible? Two matrices are compatible if the number of columns of the first matrix is equal to the number of rows of the second matrix. So let's say the first matrix A is a m by n matrix, meaning it has m rows and n columns. And B is a n by p matrix. And so this means that the matrix B has n rows and p columns. Alright? So the number of columns of the first matrix A, which is n, must be equal to the number of rows of the second matrix B. Yes, and so A and B in this case would be compatible. Alright, and also the resulting matrix will be a m by p. Now, the best way to do this is with an example. By doing an example, you'll see that it is a lot easier. Alright, so to multiply two matrices, we multiply row by column. We multiply the row of the first matrix by the column of the second matrix. Example, A, B, C, D is matrix A and B is E, F, G, H. To multiply A times B, we'll go first row of the first matrix times the columns of the second matrix. It's row by column. So it's A times E plus B times G to give us our first element in the product matrix. Then A times F plus B times H. Then C times E plus D times G. Then C times F plus D times H. Now, we're going to do examples and it's going to be very, very, very easy when you see the examples. So, look at these examples right here. A is negative 1, 2, 0, 5. B is 2, 7, 0, 1. C is 3, 1, 0, negative 2. D is 2, 1, 3, E is 2, 1, 4, 3, negative 1, 2. Find A times B, A times C, B times D, D times E, and E times D. Let's start with the first one. So to find the matrix A times B, the first thing you do is write down the order of the matrix. Matrix A is a 2 by 2 matrix because it have 2 row and 2 column. Matrix B is 2 by 2 because it have 2 row and 2 column. Notice that the number of columns of the first matrix is equal to the number of rows of the second matrix. And so we say that A times B is compatible. The resulting matrix will also be a 2 by 2. Alright? And so let's go ahead and multiply the matrix A times B. So write it out, negative 1, 2, 0, 5, 2, 7, 0, 1. Multiplying them, we're going to write first row, first column in the color black. So it's negative 1 times 2 plus 2 times 0. That's first row of the first matrix times first column of the second matrix. Alright, that works out to be negative 2. So that's the first element in A times B. Next in the color yellow, we're going to work out first row of the first matrix times second column of the second matrix. So that's negative 1 times 7 plus 2 times 1. Alright, and that works out to be negative 5. And so negative 5 is the second element inside the matrix A times B. Now, we're going into the second row now. So it's second row of the first matrix times first column of the second matrix. So that's 0 times 2 plus 5 times 0, which is still 0. So we can put 0 there as our next element in AB. Then finally we'll go second row times second column. Second row of the first matrix times second column of the second matrix. 0 times 7 plus 5 times 1. That works out to be 5. We did that in the color white. And so we put that in. And so the product A times B is negative 2, negative 5, 0, 5. That is how we multiply two matrices. So go ahead and attempt this question. Using that same principle, work out the product of A times C. So as you would have paused and attempted, we would say that A is a 2 by 2 matrix and C is also a 2 by 2 matrix. And so we note that the number of columns of the first matrix is equal to the number of rows of the second matrix, both being 2. And so A times C is compatible and the resulting matrix will be a 2 by 2. Cool. So we need to work out first row of the first matrix times first column of the second matrix. I would put that in black. Negative 1 times 3 plus 2 times 0, which is negative 3. Alright, so that's the first element in the product matrix, A times C. In the color yellow now, we're going to go first row of the first matrix times second column. So that's negative 1 times 1 plus 2 times negative 2. That's negative 5. Cool. So we put that in the product matrix. Now we need to go second row of the first matrix times first column of the second matrix. We put that in the color red. That's 0 times 3 plus 5 times 0. We get 0, so we'll put that in. And finally, we need to go second row of the first matrix times second column of the second matrix. So that is 0 times 1 plus 5 times negative 2, that is negative 10, of course. Alright, that is negative 10. And so we put negative 10. And so we end up get negative 3, negative 5, 0, negative 10. And that is A times C. So go ahead and work out the matrix product of B times D. Now looking at matrix B at the top, 2, 7, 0, 1, B is a what? B is a 2 by 2 matrix and D is a 3 by 1 matrix. Now notice that we put in the color red. Look at that, the number of columns of the first matrix B is 2, and that's not equal to the number of rows of the second matrix D, because D have 3 rows. And so B times D is not compatible. And so BD is not possible. We cannot multiply these two matrices. Nice. What about finding D times E? Can we do that? Now, if you had said we cannot do that, you are absolutely right. We see that D is a 3 by 1 matrix and E is a 2 by 3 matrix. So we see that the number of columns of the first matrix D is not equal to the number of rows of the second matrix E, because D has one column but E has two rows, and so D is not compatible, and so we say that D times E is not possible. Alright, now what about finding E times D? Is this possible? Absolutely. So to find the matrix product E times D, E is a 2 by 3 and D is a 3 by 1. So we see that the number of columns of the first matrix E is indeed equal to the number of rows of the second matrix D. And so we can just go ahead and multiply them now. So E times D is compatible and the resulting matrix is going to be of order 2 by 1. So E times D, we go first row times first column, first row of the first matrix times first column of the second matrix. All right, and so that is going to be 2 times 2 plus 1 times 4 plus 4 times 3. That works out to be 17. Then we're going to go second row of the first matrix times the column of the second matrix. So that's 3 times 2 plus negative 1 times 1 plus 2 times 3. That works out to be 11. So the matrix product of E times D is 11. So that's it. That's it for today. All right, we worked out the matrix E times D, and that's 17, 11. And so anytime you're multiplying two matrices, first thing we need to check is their compatibility. Two matrices can be multiplied, or they're said to be compatible, if the number of columns of the first matrix is equal to the number of rows of the second matrix. Alright, so that's it for today. So stay tuned for more from CXC Math TV. Stay blessed and have a wonderful day.